Okay, I hope you managed. So let me show you how I would do this. So the same as before, I'm going to copy my equation. So this is the exponential model. It's called the exponential model because x appears as an exponent. So I'm going to start this one with the spacing between the linear and the next model. And this is the exponential model, and this is the equation which I just copied, and I will format it in the same way. So I copy the formatting for this, and as before I will move Alt Enter the equation on a new line. Now this equation is written a bit differently. It's written like this: y equal a times exponent, so this is E in this case, B times X. So you can see there that I have this coefficient for X, right? So I can write it in this way. And let me remove these times, just, or maybe let's leave them because it's a bit difficult to see here. So for us, the exponent is E, right? So that's our equation. Now, who is B? Well, in this case, B is minus 0.005, and A is 466.51. Okay, so I have the A and the B. And this is the equation that I'm using. So I need to create two more columns. In this case, this is the predicted demand with the exponential function. So I'm going to change this, the exponential. Maybe like make it a bit smaller. I mean, so I will just put exp, and you know that this is the exponent function. And the same, I have to calculate the error for the exponential function. How do I do that? Well, I use the function. So I say equal, so this is the y. I'm calculating the y, which is the predicted demand, A. So I do A times. Now here I have to have the exponent. So Excel has a function called exp. So returns E raised to the power of a given number. So I want to write the exponent. And what's the exponent? Well, the exponent is B times X. So B is here times X. Well, X is the price. So I'll take the price from there. Enter. So this model is predicting a demand of 49.16. Now, of course, the demand has to be whole numbers, so you could round them, right? But let's leave it as it is. And what do I want to do? Calculate the loss. Now the error. So the error is the predicted demand minus the same as before, the real demand, which is on column C. So you can see that in this example, for the price for 50, my exponential model is better at predicting demand because the difference between the predicted demand and the real demand is smaller. So I will need to do the same thing, the same calculations for all the prices going down the row. And as before, I will need to fix some things. I will need to fix D23. So this is where A, or the intercept, is taken. And I need to fix D22, and this is where B is taken. So I will go to fix those two, and I'm ready now to drag this one further down. So to calculate all the demands, and let me format this one as a number. So maybe you can even format it with no digits. I mean, you can do the same thing here. I mean, since we are not interested in you know, you have to sell a full unit, not with not in parts, right? And the same, I can calculate the difference now between the predicted demand using the exponential model and the real demand. And again, as before, let's try to put this one as a number, and I'm going to format everything like that. And let's put also here some borders. Okay, so I'm done with the second model, with the exponential model. I've just calculated the predicted demand and the error in the predicted demand. Okay, and let's do the last one, which is the power model. So I'm going to go in here and do the same thing, copy the equation, and I will go down here and I will leave a space, and I will say that this is the power model, and the power model use that equation. And as before, I will copy the formatting like that, and let's write what type of equation is this. So this equation is y equal some kind of number a plus b times x to the power something, x to the power, in this case is minus 1.908. So this is my equation, and let's make this one a little bit smaller so you can see it. So that's the equation that I have in here. Let me see if I wrote this one properly. No, so I think actually this one is a times x to the power b. Okay, so a is all this thing here. Now, if you look in here, this is actually a number which is basically 6 to the power, some kind of small power there, you see. So we want to actually write that as a number that we can see, not in the E notation, so that we can write our A and a B as an actual number. I mean, you can leave it like that if you want. But I'm going to show you how to write this one as a number that you can actually see. So let's copy the B in here, because the B is easy to see. Yeah, so B is minus 1.908. And let's look at A. So to do that, I'm going back to the equation, right? So this is my equation here, is the power. And you can format how this is written, right? So let's have a look where we can format. So I think I probably have to select this, right? And look to see where we can format the actual label. So let's go to the text, no? Here, no? Okay, and probably is in some of the other ones. Text direction, chart, category, number. So I'm going to make this one a number, right? And you can see once I make it a number, then it actually appears as a number. So it's 5 million, it's somewhere like a 5 million, right? So it was 6 to the power 10, 6 times, right? It was a power 6, 10 to the power 6, which is what we have in here. So what I'm going to do now is, since I have the actual value without writing this in the E notation, I can copy this further down. Okay, so I'm going to go in here and replace this 6E, yeah, to the actual number that I have, which is 5,871,064.20. So that's actually my A, and I'm going to write the A in there. Let me just remove. Okay, so I have A, I have B. So I have my equation and I can predict the demand. So I'm going to copy these ones across, but instead of exponent is the power. So I have the power function and I use the equation in the same way. So it's equal and I follow the structure of the equation. A times power. Who is raised to a power? Well, the price is raised to the power. Which power? This power, B. And I close the bracket. And this is predicting a demand of 50, the power model. And I do the same thing as before. I fix the numbers that I don't want to change, as I will copy this across the row. So I'm going to fix the A and I'm going to fix the B, the exponent coefficient, and I'm ready to drag this one down. And let's check that is working properly. Yeah, so this is working properly. And I do the same thing as before. I calculate the error. So the predicted minus the real. There you are. And I can drag this one down. And as before, I will copy the formats from here to there. So they all look the same. So I am done with calculated the predicted demand using all these three models and also the error. So if I want to see this slightly more clearly, I can change the background color for this just so that they appear a little bit separated from each other. Maybe let me increase the color strength a little bit more. Okay, so I have the linear and this is the real one. So let me just format this one like that. So I have the real demand. I have the predicted demand in terms of the linear model, predicted demand in terms of the exponential model, and predicted demand in terms of the power model. And of course, you want to choose the one that has the lowest error, because that's going to be the one closer to the reality that you've observed through historical data. So let me stop here. Hopefully you have managed to do what I did, which was to use these three models to predict demand.